Hello and welcome to the second part of EC2151 Electric Circuits and Electron Devices Basics 2. Here we are going to understand the basics of a circuit and understand how a series and parallel circuits work. A circuit can be differentiated in many ways. So mainly for respective to the subject, we need to know what is an open circuit, short circuit and series and parallel circuit. A circuit is considered to be open when it has a infinite resistance so that the current is equal to 0. A circuit is considered to be short when the current is equal to maximum and the resistance is almost 0. It's not equal to 0. Remember, any circuit will have, any component will have its own resistance power, right? So it is considered to be negligible resistance, right? So this is the first diagram is an example of a open circuit where there is no connection between this point and this point, which means the resistance R equals infinity, right? So the resistance R equal to infinity, so the current I equals 0, right? So this is the example of a short circuit where the current starts from this point and ends at this point where there is no resistance available throughout this circuit. So the resistance is almost equal to 0 and current is maximum. Series circuits. The components in a circuit is considered to be series if the current is not divided between the components. So the property of a series circuit is the current remains a constant but the voltage differs. We will be seeing these proofs in a pictorial. We will be doing some calculations and the equivalent resistance is calculated by adding the resistances. So this is the pictorial representation of a series circuit. Here we have a current source which is connected to a bulb and then connected to a TV and then connected to a fridge. So if a current starts from the source, right, so it passes through the bulb, then it passes through the TV, then passes through the fridge and it ends out here, right? So the circuit is again closed, right? So instead of every time we are having a TV and a bulb, we are just denoting it in terms of resistances with their resistance values, right? So we have a current source which is giving a 1 milliamps of current which is passed to the bulb which has a resistance of 1 kilo ohm, a TV which has a resistance of 10 kilo ohm and fridge which has a resistance of 100 kilo ohm, right? So the voltage approximately will be equal to 1 milliamps, so this voltage will be 1 volt, right? So this is the Ohm's law, V equals I into R, right? I equals 1 milliamps, 1 kilo ohms, so the voltage is equal to kilo and milli will cancel, so we'll have 1 volt, right? So this will be equal to 10 volt again, this will be 100 volts. Parallel circuit. Contradictory to the series circuit, parallel circuit, the current is divided between the components. The property of a parallel circuit will be the current differs but the voltage remains the same. The equivalent resistance is calculated by adding the resistance, by adding inverse of the resistance. I am sorry, this is wrong. By adding inverse of the resistance, 1 by R equivalent equals 1 by R1 plus 1 by R2. Generally, for simplified calculations, we take only the two components, we reduce it, and then we will with that value we will reduce it the third component, right? So for simple calculation, we can consider R equivalent equals R1 R2 divided by R1 plus R2. So this should be, this is very much important formula and it should be memorized by the student, right? This is a sample circuit of the parallel circuit where I have connected the bulb, TV and fridge in parallel combination, right? So when the current comes out from the source, right, so it goes here and from here it splits. A part of the current goes to bulb, a part of the current goes to TV a part of the current goes to fridge, right? So as I told before, on the before formula, R equivalent equals R1 R2 divided by R1 plus R2. So here we are taking only two resistances, R1, this resistance 10 kilo ohm, right? We are taking this resistance 10 kilo ohm and 100 kilo ohm, right? So R1 R2 divided by R1 plus R2, 10 into 100 kilo ohm divided by 10 plus 100 kilo ohm, which is 110 kilo ohm. So 10 kilo ohm into 100 kilo ohm divided by 110 kilo ohm, which will give you 9.09 kilo ohm, right? So again we have one more resistance here, which is 1 kilo ohm, right? So now these two resistances, these two resistances will have a resistance value of 9.09, right? So these two resistances has a equivalent of 9.09 kilo ohms, right? So now 9.09 into 1 kilo ohm, this 1 kilo ohm, right, plus divided by 9.09 kilo ohms plus 1 kilo ohm. 9.09 kilo ohm plus 1 kilo ohm, which will give you an answer of 0.9 kilo ohm. So the whole resistance of this circuit is 0.9 kilo ohm, right? Voltage division rule. The voltage division rule is used to calculate the voltage across a component. The voltage across a component is equal to the total voltage multiplied by a resistance of the component divided by total resistance of the remaining circuit, right? So in this example we have considered a voltage source which is giving a 5 volt supply, right? And we have again a 1 kilo ohm, 10 kilo ohm and 100 kilo ohm, right? So we are just going to prove the theorem works out. We are calculating the value of I is equal to V by R as per Ohm's law. So V is equal to 5, I equals R, resistance, total resistance. These are connected in series. So the equivalent resistance, to calculate the equivalent resistance, we are adding these resistance values. So it's 1 kilo ohm plus 10 kilo ohm plus 100 kilo ohm. So we will be getting 0.045 milliamps. This is the current that is flowing through this circuit, 0.045 milliamps. So the voltage across 1 kilo ohm will be equal to 0.045 volt, because V is equal to I into R. So I equals 0.045 milliamps and R equals 1 kilo ohm. Kilo and milli will get cancelled. Kilo is 10 power 3 and milli is 10 power minus 3. Both will get nullified. So we will be getting 0.045 milliamps. Voltage across 10 kilo ohm equals 0.45 volt, right? And voltage across 100 kilo ohm equals 4.5 volt. Now if we calculate 4.5 plus 0.045 plus 0.045, it comes to 5 volt, right? And this is a very important derivation, which is very important inference, which will be explained in the next tutorial, but just have a look into it. By adding these voltages, we are getting this 5 volt voltage, right? So this is our normal working procedure, right? By now we are going to solve this circuit using the voltage division rule. So the voltage across the component is equal to total voltage into resistance of the component divided by total resistance of remaining circuit, right? So here if we take voltage across 1 kilo ohm equals total voltage is 5 volt, the resistance of the same component. So we are going to calculate the resistance on 1 kilo ohm. So the resistance 1 kilo ohm divided by total resistance of the circuit, 1 kilo ohm plus 10 kilo ohm plus 100 kilo ohm. If we calculate it, we will be ending up with a value of 0.45, which is similar to 0.45. here. This is our traditional method, right? This calculation is a traditional method how we calculate the voltage across each component, and this calculation is how we calculate the voltage by using voltage division rule, right? I repeat again, this is our traditional method, and this is by using the formula of voltage division rule, right? So for similarly for our voltage across 100 kilo ohm will be equal to 5 volt. 5 volt is the total voltage supplied, and to 100 kilo ohm, the resistance 100 kilo ohm divided by the total resistance 1 kilo ohm plus 10 kilo ohm plus 100 kilo ohm, which is equal to 4.5 volt. See, we got 4.5 volt in our traditional calculation, and is the same value as the applying the formula voltage division rule. Next is the current division rule. Current division rule is used to calculate the current flowing through the component. The formula is total current into opposite resistance. Make sure for to calculate the voltage we have resistance of the same component. Here the resistance of the opposite component is calculated, right? So let's say 1 milliamps current is flowing through this circuit, right? So R equivalent will be equal to 10 kilo ohms, right? So we have two resistances which is opposite to 1 kilo ohm, right? And we need to calculate the equivalent resistance of these two components. It's 10 kilo ohm into 100 kilo ohm divided by adding these two, R1 R2 divided by R1 plus R2. It gets you 9.09 kilo ohms. So this is the R equivalent for these two resistances. So the current across 1 kilo ohm, will be equal to total current 1 milliamps, right? So this total current, right? This total current 1 milliamps into opposite resistance is the equivalent of these two resistances 9.09 kilo ohms divided by sum of resistances, the total resistance of the circuit, right? So it is 1 kilo ohms plus 9.09 kilo ohms, which will give you an answer of 0.891 milliamps. So this is the current that flows through the 1 kilo ohm resistance. Similarly, if we calculate for 10 kilo ohm resistance, so here you see out of 1 milliamps, 0.891 milliamps of a current will be moved on this way, right? So the amount of current that is flowing through this path here will be 0.11, right? Can you understand why? Because 0.891 is already flowing through this area, so here only 0.1 milliamps of the current will be coming through this branch, and here if you want to calculate the current that is passing through 10 kilo ohms, you will consider 0.1 milliamps into, that is the total current, into 100 kilo ohms, because this is the only opposite resistance, 100 kilo ohms divided by addition of two resistances. Only these two resistances are there in the circuit now. This is already been calculated, so we can omit it. So only these two currents are considered, only these two resistances are considered. So it is 0.1 into 100 kilo ohm divided by 110 kilo ohms, which will give you an answer of 0.099 milliamps, right? So out of 0.11 we have 0.09 milliamps of current will be flowing to this path. So the remaining current will be flowing to 100 kilo ohms, which is equal to 0.09 milliamps, right? So if we calculate the voltage across each by the formula V equals I into R, Ohm's law. So we know the value of I now, and if we calculate I is equal to 0.891 milliamps and R is equal to 1 kilo ohm, it will be coming approximately to 0.9 volts, right? So The voltage across all components in a parallel circuit remains the same, where the current differs. For a series circuit, the current remains the same and the voltage differs. So far what we have learned is how to differentiate a series circuit and a parallel circuit. As a circuit is said to be series or parallel depends on the movement of the current through the circuit, and simple calculation of how a voltage and current can be determined across a component. Right? Thank you.